Testing, one, two, three, and this is Dr. Harmon, and have sent you guys this link, which I'll send it to you through the email over at Jupiter. I'm going to share my screen here. I'm going to talk about the solution for PAR nonlinear. This will save us a little bit of class time. I'm using Zoom, which is a platform the university is licensed is using. And I can do this with the video, but I'm not going to do the video today, simply because I'm here at the house. It's Saturday morning, and whatever. But hey, I'm working. I don't know what you're doing. Anyway, I'm going to show you what I was after. Some of you took kind of a longer approach to get this done, but I will show you what I'm trying to get done. Okay, I'm going to share the screen, the desktop. And you're going to see the PAR nonlinear key file. I have that hidden from you over there. But basically, here's what I'm after. And we'll talk about this very quickly. This is from Appendix 8.2, pages 407 to 409. And I ask you to use a what-if analysis tool to obtain a value of 65,000 in cell B18, okay, which is the maximum profits. In this file, in this instance, don't use the data table function. Well, a what-if function is quite simple. We have two of them. So I eliminated the data table, so the two that are left, and we'll click on data. And on the what-if analysis, or scenario manager and goal seek. Let's click on scenario manager, okay? And pardon me, on the goal seek, excuse me, on solver. And of course, I'll try to solve it, and it's not going to give me, there's no solution to maximize that to get to 65,000. So we're going to have to resort to doing just a little bit more work here. And I said use a what-if analysis tool. So the thing to use would be goal seek. And I can try the scenario, but I'm going to try this direct goal seek, as is mentioned right here in step number 2. Let me take this down just a hair so you can see a little bit better. Now, I'm going to sell B16, the standards. I tried to, first of all, by how many bags I'm going to produce. That didn't work. I tried changing the number of deluxe bags produced, okay? And then I decided, okay, let's try marginal cost. So I'm going to start with the marginal cost for the deluxe bags, which is right now is at 150. And so I'm going to come over here to what-if analysis. I'm going to click goal seek, and I'm going to set the cell B18 to 65,000, and by changing cell C9, and I'm going to run it, and I get a value, and that is if I can get the marginal cost of the deluxe bags down to 101 bucks, I can reach my goal of 65,000 maximum profit, okay, which means up here, I'm going to have to change something in terms of the cutting and dyeing, because in order to increase, to decrease the marginal cost, and marginal cost, of course, is the cost for each additional unit, I'm going to have to reduce the production time for one or more of the operations that are connected to the cutting to the deluxe, making the deluxe bags. And I'm going to have to take a look at cutting and dyeing is probably going to be my number 1 candidate. Sewing will be another issue, but I'm going to have to try to find some way in there to shave $49 off of the marginal cost to get to that goal. And so that's that. So I've done a drill down now. I look at the bags produced. I said, okay, that's not going to work. So I attacked the marginal cost. Okay. Now, I'm drilling down on my solution. So I found a solution there. So if you gave me a file that had a marginal cost there on the deluxe bags of 101, you're in good shape. Now I'm going to use goal seek again. As you can see, what I'm trying to encourage you also is that when we lay out a set of data like we do using Solver, we really lay out the key variables. I mean, we develop a template. So I could use Solver, I could use the what if analysis, goal seek, and then I've got some more ways to go. So I'm going to click on goal seek, and I'm going to set the cell B18. That's the total profit. Again, I'm going to set it to 65,000. And this time I'm going to do it by changing cell B9, which is the marginal cost for standard bags. Now, again, in BISS 1123, we talked about, we did total cost. I know you've covered total cost in accounting, you've covered it in econ. Total cost equals variable costs plus fixed costs. Fixed costs are those that have to be paid. Variable costs are those that change for each additional unit that you produce that's on a per unit basis. And so when we're doing the marginal cost, you were talking about the marginal cost per unit. And so that means we're going to have to go back in and look at the cost there. If the fixed costs are what they are, that means we have to reduce the variable costs. Now, here we are, and we'll click OK. Let's see what happens. And what this shows us is that if we use standard bags, okay, if we focus on the marginal cost of standard bags, if we get those down from 70 to 37, we can hit our maximum profit goal. Okay, I have a series of questions there, and I'll scroll this back out a little bit more for you. In fact, I'm just going to scroll up because we've looked at the numbers. You can see that we stay within the parameters. And we got the standard bag price functions and the over there. Now I'm going to do something here. I'm going to change this to 37 of the marginal cost. And it does nothing to the standard bag price functions. You say, well, why couldn't I just put the cursor in there? My sister, another Facebook post of hers, it's popping up on my machine. Nonetheless, as you can see, I give you a series of questions, and let's look at those for just a moment. And I walk you through the narrative of what I've just finished. I'm basically down to, I've done 4A and 4B, and food for thought. Here is what is important for you to think about in terms of, and I'm going to highlight these. I'm going to bold up and get them up a little larger because this is what we're focusing on. Which of these you accomplish? Reduce the marginal cost for deluxe or standard bags, and why? And that would be a question you'd have to think about. You know, we talked about the marginal cost for the deluxe bags from 150 to 140 to 101. So that's a difference of $49. And again, remember these are times available. And would it be easier to do that for standard or deluxe? That's a question. And we have a certain amount of time available here. Okay. And that's those are hours. So you can see how we've got things allocated. And the question is, how can it be possible I can increase maximum total profit by reducing marginal costs? Well, I mean, you know, if you don't know the answer to that one at this point in time, you know, we need to do some talking, because it's obvious. When I reduce marginal costs, I'm reducing, okay, variable costs. And when I reduce variable cost, I'm reducing total costs, which in turn increases the profit, which is total revenue per unit minus total cost per unit. So yeah, pretty simple. A little bit of thought. And then what is the marginal cost? How do I calculate it? Here's another of those questions I ask. Marginal cost is pretty simple. It's on a per unit basis. It's the total revenue or revenue per unit minus, okay, the variable costs. Marginal cost, in other words, is money I have left to pay on fixed cost. And if I have a marginal cost that's larger than my fixed cost, then I got profit. So the lower I get, the smaller I get the marginal cost, the more total profit, the more total profit I have, and the better the contribution margin. Can I adjust it without actually reducing costs? How would I do that? The marginal costs? No, not really. Unless you incurred additional fixed costs. Now that would be one way you could do it. Now, for example, automation is a way that I can build in a fixed cost. I could buy a new piece of machinery and it's going to produce, say, a unit of something at the same rate every time, and I have a loan on that machine. So that really truly is going to be it's going to be a fixed cost. Now, admittedly, as I'm depreciating it out, that's going to be a different question, because as I'm doing the depreciation of the use of the machine, theoretically, I'm absorbing a variable cost. Truth is, if I have a machine that'll make $1 million or 10 million or how many ever, and the depression, pardon me, not depression, but the depreciation is there. But let's not forget, depreciation is a what? Non-cash expense. And I used the goal seek. Was there any other variable I might have tried? Well, the other variable would be time available. And just for kicks, let's do that. We've got the time available over here. And let's just go ahead and I'm going to click data again. I'm going to go to what if analysis. I'm going to do goal seek, okay? And I'm going to set cell B18, that's our profit, to 65,000 by changing the cell D5. That's the time available for cutting and dyeing. And let's see what happens. It's going to work through it, see if it's going to find us a solution. And it really doesn't. It gives us some nonsensical number. So that's not going to work. So we'll cancel that out. Let's try the time available for sewing. Again, we're playing with that time factor, which implies labor costs, maybe or cost for a machine. And we'll use the goal seek. And I'm going to try B18 to 65,000. By changing cell, this time it's going to be cell D6, which is sewing. Let's see what we get. We'll probably get some nonsensical value again. Remember now, we're using an evolutionary apartment. We're not using solvers. We're not doing anything like that. We'll cancel that out. And so you can see it's unlikely that if we go through the rest of the time available figures, that time available, total time available, that we're not going to be able to do anything. So we could drill down over here also. Let's look at the cutting and dyeing. Now let's try goal seek. I'll set that B18 to 65,000 by changing the cell B5, which is the production time spent on cutting and dyeing. Let's see what we get. Again, we're getting these nonsensical figures. So the issue in terms of the marginal cost, so we would just have to work through here, and we're going to have the total cost and fixed cost figures there in order to get that. But we do know that we can do that because what we have right here, we have a price function. Okay, and that price is and let's look at it for a moment. It's 150. The standard bag price function equals 150 minus 1/15 times B16. B16 is the bags produced. And then for the deluxe bag, we have 1/5, and it equals 300. And remember in our functions up here, remember in the objective function back in the text, these price functions, those are exhibited there. Those are exhibited there in the text in the objective function expression. Pardon me. Okay, and we can see, let's look at this for a minute. It equals B27 times B16 plus B28 times C16 minus B9 minus B16 minus C9. So here we have the standard, and so that maximum total profit equals B27, which is the standard, which is the price for standard bags, times the bags produced minus C16, pardon, B28, which is the deluxe bag price function, times C16, which is going to be the deluxe bags produced minus B9, which is the marginal cost, times C16. So you can see we do have the price function. We can work through that process. It's the marginal cost that's the key. So we're going to have to come back in. The marginal cost, now notice here, we have production time, which implies costs, okay? And we could change the price variable, but that imposes a lot more risk. And I have some, some interesting, some food for thought or some things for us to think about. So that's it as far as par nonlinear. That's what was due. And I was looking for you to find reducing the marginal cost for standard bags to 37, leaving deluxe fixed at 150, or change the deluxe to 101, leaving the marginal cost for standard at 70. And you, of course, could have used a scenario manager to work the two variables, the two marginal cost figures. Okay, that's pretty much it. And I'll stop the share now and then stop the recording. I'll go back to the meeting here. And so I'll stop the share, and then I will go ahead and in the recording. And that'll be it. Thanks for your time. And that is the power nonlinear case.